Part 1. The rifle arrived at the Abakan testing facility in Kovrov in September 1993, packed in foam inside a military transport case. Gennady Nikonov stood in the observation room while range officers removed the AN-94 from its container and placed it on the examination table. The equipment looked conventional at first: stamped steel receiver, polymer furniture, side-folding stock. But when the lead evaluator released the dust cover, the internal architecture revealed itself. "There are cables inside," the officer said. Nikonov nodded. "The barrel assembly is displaced. It moves independently during operation." The room went quiet. Soviet rifle design had followed a single principle since 1947. The receiver is fixed, the bolt moves, the barrel remains stationary. Mikhail Kalashnikov had built an empire on this logic. The AK-47, the AKM, the AK-74 all shared the same fundamental architecture. Nikonov had abandoned it. The Abakan program had begun 12 years earlier with a specific mandate: develop a rifle that increases hit probability without changing ammunition or increasing weight beyond acceptable limits. The Soviet army had observed that personnel using automatic equipment rarely hit targets beyond 100 meters. Recoil disrupted aim. Muzzle climbs scattered rounds. The mechanical problem was simple. The hardware moved faster than the projectiles could leave the barrel during sustained use. 47 design teams had submitted proposals. Most attempted to reduce recoil through muzzle brakes, balanced bolt systems, or advanced materials. Nikonov had chosen a different approach. Don't reduce recoil, delay it. If the device could discharge 2 rounds before the operator felt any force, those rounds would travel toward the same point of aim. The 3rd and 4th rounds could scatter, but the first 2 would group. The evaluator picked up the rifle, felt its weight distribution, and examined the barrel through the ejection port. "This passed preliminary trials?" "It won the Kovrov competition in 1991, Nikonov said. "We've been refining it since then." The complexity was evident. Where the AK-74 had 30 moving parts, the AN-94 had 43. The pulley system required precise cable tension. The displaced barrel assembly added mechanical stages that could fail under field conditions. But the test data from 1991 showed measurable improvement. Groups at 100 meters were 15% tighter in 2-round burst mode compared to the AK-74. The officer placed the rifle back on the table. "We'll begin cyclic testing tomorrow." The political environment has changed since this program started. Nikonov understood the Soviet Union no longer existed. The Russian Federation had inherited the Abakan program, but not its budget or its institutional certainty. The AN-94 would need to prove itself not just as superior engineering, but as affordable production reality in an economy that had collapsed. If stories like this help you see how engineering quietly shaped history, tell us in the comments what surprised you so far, and stay with us for the next chapter. Part 2. Nikonov had started the design work in 1987 at the Izhmash factory in Izhevsk, where Soviet hardware had been manufactured since 1807. The Abakan brief was specific: develop a tool that could place 2 rounds within a 15-centimeter circle at 100 meters when used in burst mode, while maintaining reliability in temperatures from 50 degrees C to plus 150 degrees C, and weighing no more than 4 kilograms. The recoil timing problem had been documented in technical journals since the 1950s. When a rifle is used, the bolt carrier moves rearward. The cartridge case ejects, the recoil spring compresses. All of this happens in milliseconds, but the recoil impulse, the backward force, reaches the user's shoulder almost immediately. If the device is set to automatic mode, the second round leaves the barrel after the hardware has already begun moving. Nikonov's initial sketches showed a conventional gas-operated system with an unconventional addition, a second layer of mechanical isolation. He imagined the barrel and bolt assembly as a unit that could travel independently inside the receiver. Springs and cables would control this movement, allowing the mechanism to complete a 2-round burst before transferring energy to the stock. His colleagues at Izhmash were skeptical. "You're adding weight and complexity to solve a problem that training addresses," one senior engineer said during a design review in 1988. Nikonov showed him the test data. "Training assumes ideal conditions. Field use doesn't. If we can mechanically improve hit probability by 15%, we change engagement outcomes." The chief concern was reliability. The AK-47 functioned in mud, sand, ice, and extreme neglect because it had few moving parts and generous tolerances. Every additional component in Nikonov's design was a potential failure point. The cable system required lubrication. The pulley mechanism needed precise alignment. The displaced barrel assembly added mass that could shift under impact. By 1989, Nikonov had built 3 working prototypes. The first jammed after 300 rounds. The cable tension was incorrect. The pulley system couldn't maintain timing under sustained use. The second prototype functioned reliably, but weighed 4.3 kilograms, exceeding the program requirements. The third incorporated lighter materials and revised spring rates. It passed the initial 10,000-round endurance test. The Kovrov Proving Grounds evaluated the third prototype in January 1991. The test protocol was demanding: cyclic use in 40-degree DC conditions, followed by submersion in ice water, followed by immediate operation without cleaning. The AN-94 completed the protocol. The hit probability data showed the predicted improvement. Nikonov's design advanced to the final round, but the Soviet Union dissolved 10 months later. The Abakan program continued under Russian military oversight, but with reduced funding and uncertain political support. Nikonov spent 1992 and 1993 refining the design for manufacturability. The cable routing was simplified. The pulley system was strengthened. The receiver dimensions were adjusted to accommodate existing Izhmash production tooling. By September 1993, the hardware on the examination table represented 6 years of iterative problem-solving. Every component had been tested, failed, redesigned, and tested again. The complexity remained. It was irreducible given the mechanical requirement. The hyperburst mechanism could not be simplified without abandoning the core innovation. Part 3. The mechanism operates in stages, each dependent on precise timing. When the user pulls the trigger in 2-round burst mode, the hammer strikes the firing pin. The cartridge activates. Gas pressure drives the projectile down the barrel while simultaneously pushing the bolt carrier rearward through the gas tube system. In a conventional rifle, this rearward motion immediately translates to the receiver, then to the stock, then to the user's shoulder. The time delay is approximately 3 milliseconds. The hardware begins moving before the projectile exits the barrel. The AN-94 interrupts this chain. The barrel assembly, which includes the barrel, gas tube, bolt carrier, and return spring mechanism, is not fixed to the receiver. Instead, it rides on 2 guide rails inside a secondary housing. When the first round is discharged, the barrel assembly begins moving rearward. But this movement is constrained by a pulley system connected to 2 steel cables. The cables run from the barrel assembly over pulleys mounted in the receiver and connect to a counterweight system near the stock. As the barrel assembly moves back, it pulls the cables, which pull the counterweight forward. The forces balance. The recoil energy is absorbed internally, converted into mechanical work within the device itself, rather than transmitted immediately to the operator. The bolt carrier completes its cycle, extracting the spent case, loading the second round and locking into place, while the barrel assembly is still traveling rearward inside its housing. The second round is discharged before the first recoil impulse has finished propagating through the system. The cyclic rate for these 2 rounds is 1,800 rounds per minute, or 33 milliseconds between shots. Only after the second cartridge case ejects does the accumulated recoil force overcome the spring tension and cable resistance. The barrel assembly reaches the rear of its travel limit. The counterweight system releases. The stored energy transfers through the receiver to the stock. The user feels the recoil as a single, combined impulse, 2 rounds delivered as one mechanical event. The engineering challenge was synchronization. The gas pressure had to be precisely calibrated to drive the bolt carrier at the correct speed. The cable tension had to allow exactly enough rearward travel for 2 complete cycles. The spring rates had to return the barrel assembly forward after the burst without causing the mechanism to cycle prematurely. Tolerances were measured in tenths of millimeters. Nikonov's design drawings showed every force vector, every timing constraint, every point of potential mechanical interference. The pulleys were not standard components. They were custom machined to specific diameters that controlled cable speed. The guide rails required hardened steel to withstand 10,000 cycles without wear that would introduce slack into the system. The hardware also functioned in conventional full automatic mode at 600 rounds per minute. In this setting, the hyperburst mechanism disengaged. The barrel assembly remained relatively fixed, and the rifle behaved like a standard gas-operated system. The selector switch controlled which mechanical pathway the device followed, hyperburst or standard automatic. Do you think this design choice was inevitable or a risky gamble at the time? Share your view in the comments and pass this story to someone who enjoys understanding how things really work. Part 4. The endurance testing phase at Kovrov lasted 4 months. The protocol required discharging 50,000 rounds through each prototype under variable conditions: temperature extremes, dust exposure, water immersion, and impact stress. 3 AN-94 rifles were submitted. 2 completed the test. 1 failed at 37,000 rounds when a cable snapped under tension during operation in 35°C conditions. The failure analysis showed that the cable material, music wire steel, became brittle in extreme cold. The pulley system increased tension during the rapid cyclic operation of the hyperburst, and the combination of cold and stress exceeded the material's fracture limit. Nikonov returned to Izmash with the broken cable and 3 weeks to solve the problem. The solution was metallurgical. He sourced a different steel alloy, one used in aircraft control cables, with higher nickel content for low-temperature ductility. The cables were replaced in all prototypes. Testing resumed in February 1994. All 3 devices completed the full 50,000-round protocol without cable failure. The next evaluation phase was field trials with active units. The Russian Army selected the 12th Guards Brigade for testing. Personnel received 10 AN-94 rifles and 5,000 rounds of ammunition. The test period was 6 weeks. The feedback was mixed. Positive reports noted the improved accuracy in short bursts. Users observed tighter groups at 100 meters compared to their issued AK-74s. The hyperburst felt unusual, a delayed double-tap sensation, but became intuitive after 200 rounds of familiarization. The hardware's balance was good, the folding stock was sturdy. Negative reports focused on complexity. The AN-94 required more cleaning time than the AK-74. The cable system needed periodic inspection. Personnel noted that disassembly for field maintenance was more involved. The pulley housing had to be carefully handled to avoid damaging the cable routing. In muddy conditions, the guide rails accumulated debris that affected the smoothness of the barrel assembly's travel. One sergeant submitted a detailed report. "This rifle is more accurate, but it is not more practical. We can maintain accuracy with the AK-74 through training. We cannot train the AN-94 to be simpler." Nikonov read every field report. He understood the criticism. The AK-47 family had succeeded because it worked under abuse, neglect, and minimal maintenance. The AN-94 required care. It was not a tool for every individual. It was for professional units with time to train and maintain equipment properly. The Russian military leadership reached a similar conclusion. The AN-94 would enter limited service, issued to special units, airborne groups, and guards formations. Standard personnel would retain the AK-74. Production numbers would be modest, approximately 2,000 units per year, a fraction of the AK-74's output. Nikonov accepted this outcome. The goal had never been mass replacement. The goal had been proving that mechanical innovation could improve performance. The AN-94 demonstrated that recoil timing could be controlled through clever engineering. The device existed. It functioned. It validated the principle. Part 5. The final curiosity about the AN-94 is not that it works, it's how it works within the constraints of 1990s Russian manufacturing. The hyperburst mechanism could have been achieved with electronic firing controls, servo systems, or computerized timing. Nikonov used none of these. Every component is mechanical, visible, and understandable with basic tools. The pulley system is the key insight. Pulleys redirect force without consuming energy. By routing the cables over precisely sized wheels, Nikonov created a mechanical computer, a device that performs a calculation through physical motion rather than digital processing. The calculation is simple. Delay the transmission of recoil force by exactly the time needed for 2 firing cycles. This approach required no power source beyond the propellant itself. The gas pressure that drives the bolt carrier also drives the barrel assembly. The springs that return the mechanism to its starting position also store and release the recoil energy. The system is closed, self-contained, and requires no external inputs. It cannot fail electronically because it has no electronics. The trade-off is mechanical complexity. Electronics can execute complex timing sequences with minimal moving parts. Mechanics require multiple components working in precise coordination. The AN-94 has 16 additional parts compared to the AK-74, each of which must be manufactured to tighter tolerances. The cable tension must be set during assembly and verified periodically. The pulleys must rotate freely without binding or wobble. But this complexity is transparent. A trained technician can disassemble the AN-94, inspect every component, and understand exactly how the mechanism functions. There is no hidden logic, no proprietary software, no black box. The hardware is entirely knowable. This philosophy reflects Izhmash's institutional knowledge. The factory had been building hardware since the Napoleonic Wars. Its engineers understood that military tools must survive decades in inventory, must be repairable in field conditions, and must function regardless of the technical sophistication of the user. Electronics age poorly. Software becomes obsolete. Mechanical systems, properly designed, endure. The hyperburst mechanism represents peak mechanical ingenuity, the maximum performance achievable without leaving the domain of springs, cables, and steel. Nikonov could not make the AN-94 simpler without abandoning the core innovation. He could not make it more sophisticated without introducing components that Russian factories in 1994 could not reliably produce or that personnel could not reliably maintain. The hardware sits at an inflection point in technical history. It arrived after the AK-47 had defined what a military rifle should be: simple, robust, maintainable by anyone. It arrived before digital fire control systems became standard. The AN-94 is the last generation of purely mechanical innovation, the end of a design tradition that began with early systems in the 1800s. The final curiosity is temporal. The AN-94 was engineered for a Soviet military that no longer existed by the time production began. It succeeded technically, but arrived into a geopolitical reality that could not support its full deployment. The device proves its principle. Recoil can be mechanically delayed, but the principle arrived too late, too complex, and too expensive for the army that requested it. Part 6. The AN-94 remains in service with Russian special units. Approximately 50,000 rifles were produced between 1994 and 2006, when production largely ceased. The hardware is recognizable in photographs from training exercises. The distinctive receiver profile, the side-folding stock, the slightly forward center of gravity due to the displaced barrel system. No other organization has adopted the design. The complexity and maintenance requirements make it unsuitable for export or license production. The tool exists within a specific institutional context: the Russian military's tolerance for specialized equipment in elite units. The AK-74M remains standard issue for general forces, exactly as the field trials predicted. Engineers study the AN-94 as a case study in creative constraint. Nikonov faced a specific problem. Recoil timing affects burst accuracy. He had specific tools: Soviet-era manufacturing capabilities, no electronics, a 4-kilogram weight limit. His solution was geometrically elegant. Isolate the mechanism in a moving platform, control its motion with cables and pulleys, and synchronize the timing through spring rates. The hardware demonstrates that mature technologies still contain unexplored design space. The standard rifle had been considered a solved problem by 1980. Gas-operated, magazine-fed, select fire, the architecture was settled. Nikonov showed that the architecture could support radical internal revision if the designer was willing to accept new forms of complexity. The AN-94's legacy is academic more than operational. It appears in technical textbooks as an example of alternative approaches to recoil management. Engineers reference the pulley system when discussing mechanical delay mechanisms. The hardware validates a principle without displacing the simpler design it was meant to replace. Nikonov continued working at Izhmash until his retirement, designing modifications to existing systems and consulting on technical projects. The AN-94 remained his signature achievement, the proof that mechanical ingenuity could still advance technology at the end of the 20th century. The rifle sits in an unusual category, too complex for mass adoption, too functional to dismiss as a failure. It works. It improves hit probability measurably. It requires maintenance that users can provide if they are trained and equipped properly. The question was never whether the AN-94 could succeed technically. It answered that in 1994. The question was whether the military environment would support a tool that demanded more from its users. The answer was partial. Elite units received the device and used it effectively. General forces did not, because the institutional structure optimized for universal reliability. The AN-94 asks users to care about their equipment, to maintain it properly, to understand its mechanical logic. The AK-74 asks nothing beyond basic cleaning and loading. Engineering advances when constraints force creativity. Nikonov faced economic collapse, institutional skepticism, and a mandate to improve performance without access to advanced materials or electronics. He succeeded by returning to first principles, not how do we make a better rifle, but how do we make it discharge twice before it moves? The answer was mechanical choreography, a dance of cables and springs timed to millisecond precision. The AN-94 is the device Russia built when it could still build complex things, when institutional memory and manufacturing capacity aligned long enough to produce something genuinely innovative. It remains in limited service, a reminder that mechanical engineering reached extraordinary sophistication before digital systems replaced it. If you enjoy calm, true stories about how engineering shaped the world, subscribe to the channel, leave a like, and tell us from which country you're watching.